Hey there, Patriots. Mr. Gilbertson. So I wanted to talk today about the segment addition postulate. Thank you for participating in the first video of our geometry course. So I'm going to introduce you to a couple terms. Please have your notes available. You'll need 3 different colors and a pen or a pencil to write down. All right, so pause the video, get those available, and let's go. All right, so what is a segment? A segment is just a piece of a line. Notice that these guys have arrows. Arrows mean it goes on forever. That is a line. A piece of that line is called a segment. So this is a segment. If I start at A, and I end at B, that is what we call segment AB. It starts at A and it ends at B. So the segment in yellow is segment AB. Let me move that a little bit out of the way. Alrighty, I could also, if I wanted to, I could start at B and I could go to A. So if I went the other way. I started at B and then I ended at A. That is segment BA. Notice when I put a segment over the top, there's no arrows on it because a segment starts at one letter and ends at another letter. Please notice AB and BA are the same segment. Segment AB is the same as segment, let's just erase. If you make a mistake, correct it. And that is segment BA are the same. Because it starts at one point and it ends at another point. You'll notice the yellow segment and the blue segment are the same. So we said we're talking about the segment addition postulate. So what is a postulate? A postulate is a rule that we accept without proof. It's fact. Every time we do it, it works. So in this case, every time I do the segment addition, the postulate works. Every time we do a postulate, it works. However, I can't sit down and prove it. I'm going to put works in quotes because works just means that what it is it works. So the segment addition postulate always works. Well, the segment addition postulate requires us to use the word collinear. Collinear is a set of 3 or more points that are all on the same line. At least 3, so it's 3 or more. So if I give you 3 points, point is a location in space, and let's label them points G, E, and O. Notice I am using capital letters. These points are all collinear because I can connect them with one line. So G, E, and O are collinear. They are collinear because all of them are on the same line. If they're on the points on the same line, are collinear. Points not on the same line are non-collinear, non being not. So if we start off, let's start off with our same 3 points again. Let's start off with point G, point E, and point O. Well, if all we have is those 3 points, they are collinear, but we're going to do this. I am going to add in point Y. Can I draw one line through all 4 of those points? And that answer is no. So when I add Y to the mix, now G, E, O, and Y, because I added Y, if I'm adding Y to the group, that makes them non-collinear. Collinear, linear being line. So they are non-collinear. They are all not on the same line. So go ahead and turn your page. So the segment addition postulate. So I'm going to a segment, a piece of a line. Addition, I am going to add, and a postulate is a rule that always works. So the segment addition postulate says if there are 3 collinear points, G, E, and O, G, E, and O, they are collinear, they are on the same line. Where E is between G and O, then GE plus EO equals GO. Notice there's no segment line on top anymore. So what that means is that, I'm going to make this a little thicker. What that means is that now we're talking distance. The distance from G to E plus the distance from E to O equals the distance of the whole thing. The length of the front part plus the length of the back part equals the length of the whole thing. That's what this postulate is saying. GE, the length of GE, there's no segment on top, plus the length of EO equals the length of GO. That is the segment addition postulate. Piece plus piece equals whole. Part plus part equals whole. That makes sense. If you add up all the pieces, you get the whole thing. That's why it's a postulate. It makes sense. So if I give you a diagram that looks like this, let's write that segment addition postulate. The segment addition postulate says part plus part equals whole. Well, what parts? The front part plus the back part equals the whole thing. So how long is the front part? Well, the front part is from E to O long. How long is the back part? From O to G, and the whole thing is from E to G. That's the segment addition postulate. So EO plus OG equals EG. Part plus part equals whole. If I mix the letters around, the order of the letters doesn't matter as long as I got 3 collinear points. I can say front part plus back part equals whole thing. I forgot to put the blue up there at the same time. So the length from O to G, length of OG plus the length of GE equals the length of OE. Boom. Easy peasy. Well, what if I don't give you words? So first, I'm going to want you to draw and label the described segment. And then we're going to write the segment addition postulate. So the described segment says B is between F and R. So I need to draw a segment with 3 points, and it said B is between F and R. So there's my segment. B is between. Now, let's highlight. Please get in the habit of highlighting. Some of you are like, I'm too cool for highlighting. Let me just tell you, no, you're not. Yellow plus blue equals green. That is super easy to remember. So the length of FB plus the length of BR equals the length of FR. And on your test, I'll probably be asking, hey, are you using colors? Let's try L is between T and M. Let's draw this segment as described and then write the segment addition postulate. So we have 3 points, L, T, and M, where L is between T and M. So when I highlight, I'm going to go yellow, the yellow part, the front part, plus the back part equals the whole thing. So let's hit that up. The yellow part is TL. The length of TL plus the length of LM equals the length of TM. Part plus part equals whole. That wasn't so bad. So please have these notes completely filled out. Hopefully you're using your colors. Come into class. Please have any questions that you still might have regarding this. There's going to be a bell work question about this right when you get in. So Patriots, I'll see you when I see you, and I hope that you're having a good one.